f of n is 1 plus 2 plus 3 plus 4 till n plus 1, and g of n is sigma k equal to 1 to n 1 by f of k, the least value of n for which g of n exceeds the value 99 by 100. Calm down. I cannot process all of this, so I'm going to come down and do what is f of 1. F of 1 is 1 plus 2, which is 3. F of 2 is 1 plus 2 plus 3, which is 6. F of 3 is 10. F of 4 is 15. F of 5 is 21. F of 6 is 28, and so on. Sum up to n plus 1 integers is f of n. I have formula for that. F of 1, 2, 3 till n plus 1 is n plus 1 into n plus 2 by 2. I can say f of n is n plus 1 into n plus 2 by 2. F of 1 is 2 into 3 by 2. Yes. F of 2 is 3 into 4 by 2. Yes, that is 6. 4 into 5 by 2. 5 into 6 by 2. Yeah, nicely works. Now what is g of 1? G of 1 is 1 by f of 1. What is g of 2? 1 by f of 1 plus 1 by f of 2. G of 3, 1 by f of 1 plus 1 by f of 2 plus 1 by f of 3. So this is 1 by 3. This is 1 by 3 plus 1 by 6. 1 by 3 plus 1 by 6 plus 1 by 10, and so on. Nice. Brilliant. So now we are on to something. So we want to find g of n where g of n exceeds 99 by 100. So 1 by 3 plus 1 by 6 plus 1 by 10 all the way up to 1 by f of n should be greater than, should be greater than 99 by 100. Want to find the smallest n where this happens. Presumably it keeps on growing and it reaches a point where it is greater than this. It may be a convergent sequence but could reach more than 99 by 100 at some point of time. We need to find the smallest n for which this happens. F of n is 1 by, f of n is n plus 1 to n plus 2 by 2. So 1 by f of n, I'm going to simplify that. 2 by n plus 1 into n plus 2. Now I know I can break this into partial fractions. I know this is now 2 times 1 by n plus 1 minus 1 by n plus 2. I'm done, because the moment I write it like this, I can simplify this. So this expression becomes 2 times 1 by 2 minus 1 by 3, which is 1 by 6, 2 by 6, 1 by 3, plus 2 times 1 by 3 minus 1 by 4, plus 2 times 1 by 4 minus 1 by 5, all the way till 2 times 1 by n plus 1 minus 1 by n plus 2. This is greater than 99 by 100. The beauty about breaking into partial fractions into series like this, a bunch of terms get cancelled. Minus 1 by 3 plus 1 by, remember all of them are multiplied by 2, so I can cancel this. Finally I'll have 2 times 1 by 2 minus 1 by n plus 2 greater than 99 by 100. The smallest n where this is achieved, that's my answer. 99 by 200, so 1 by 2 minus 1 by n plus 2 is 99 by 200. Bring this to side, 100 by 200 minus 99 by 200 not equal to, greater than 1 by n plus 2. 1 by 200 greater than 1 by n plus 2. n plus 2 greater than 200. Or n, if it are 198, it will be equal. N should be greater than 198, or the minimum value n can take is 199. Absolutely brilliant question. We write as f of n, we write g of n, we break f of n expression, 1 by f of n expression into partial fractions, write the summation, and then solve for the inequality. delightfully tough question. Maybe you shouldn't be saying delightfully tough.